again. So we were talking about the decimal system, and Miss Morris was trying to explain to me what decimal is. So I was writing the number 356.75. So my question, Miss Morris, is this a decimal? Miss Morris, are you there? Hearing me?
It is, sir. It is.
I was just asking you, are you seeing what I wrote on the screen?
Yes.
Hmm?
Yes,
Yes.
sir.
Okay, so I was asking if that number is a decimal.
It is.
All right. So based on your knowledge, what is a decimal?
So as I said, sir, a decimal has whole numbers and are integers and non-integers. I don't know if I remember quite well.
Okay.
So anything that is behind the point is considered, or any number behind that point is the decimal.
Okay. So suppose I remove these numbers behind the points.
Then we would do a placeholder with 0.
Is that number a decimal?
If you remove the point, no.
Okay.
It would have been an whole number.
Miss Anushe, do you agree with her?
Yes, sir.
Okay. All right. Much to your surprise, the number that is there is also a decimal. What do you know? Why do we call it decimal though?
Sir, how is that a decimal?
Because decimals are numbers in base 10. And our number that we use, it is in base 10.
In base what? 10?
Base 10, right? Now, when we talk about decimals are special fractions, right? So if we say decimals are special fraction where with denominators with powers of 10, that would be the point, the part that comes after the point, right? And so if we have 7 after the point, then this 7 would be over 10, right? If we have 2 digits after the point, let's say 7.75, then we would have 75, we would have, instead of over 10, we would have now 75 over 100. Now, in our number system, what we do generally when we are counting, we count 1, 2, 3, 4, 5, 6, 7, 8, 9. And we go to the next place value. So every 10, we go to the next place value. You notice, Miss Morris?
Yes, sir. I'm looking what you're doing.
Right. This really means 10. And so we have been using these whole numbers, but we have been using them in the decimal system, which is base 10. Now, if you think about these, if you think of a whole number, you might say to yourself, then this is not a decimal, but it is. Because if you're thinking of this, you would know that the decimal would have a whole number part. It's a fraction. It's a special type of fraction, so it will have a whole number part. In this case, this would be the whole number part. Just as how you have ordinary fraction, you'll have a whole number part, like say 1.5. Now, even though we don't refer to this number in the context of decimal, the whole number really obeys the decimal system because we are using what we call base 10. And so just when we talk about the decimal system, the whole number part, as you count, as I had mentioned before, your place values. Let me see if I can give you an idea of what is happening. So this number would be 10 to what? All right. This 5 would be in which column? The 10th column, right? Agree?
Yes.
3 would be in which column? 100 column, right? You agree?
They said the 3.
Yeah, the 3 would be in the 100 column.
Yeah, in the 100 column, the 5 in the 10th, and
And
the
this
6
one would
in the
be
ones.
ones column, right?
Right.
And this one would be in which column? The one that comes up.
The 10th.
The 10th
The
column
10th.
with
Yes.
PH, right? And this one
Yes.
is the 100th column. Now what you will
Yes.
see is that the place values before the point, they are multiples in powers of 10. But this one here can be written as what power of 10?
To the first power.
No, 10 to the first power wouldn't give you a 1, it would give you a 10. So what value would you write this in terms of the power of 10? What could you write it in? All right, look at the second one. The 10 column could be written as 10 to what power?
The 10 column. The
Yeah.
5 column.
Yeah, the 10 column. What power of 10 this would be in? 10 here would...
The second or the third?
No, man, this 10 would be in what power? 10 to the power 1, right? This 100,
A minute.
this 100 would be to what power?
Isn't that what I just said?
No.
And you say it can't be to the 1 column. To the first power.
No, man, when I asked you the first question, I was asking about this one. I was saying this is what powers of 10 you would get 1. What powers of 10 will give you 1? I 10 to the 1, and I said, no, that wouldn't be possible for this number. You can't raise 10 to the 1 to get 1. You get what I'm saying?
Yeah.
You understand what I'm saying, Miss?
Not sure, but
all right, that's why I immediately go to the 10th column, because I want to show you a pattern going on. So this would be 10 to the what? To the 1. This one would be 10 to the what power?
the second.
Second power. And if you
And then that would be 10 to
the other one would be 10 to the what?
the third. So the first one would be 10 to the 0 power.
Yeah, the first one would be 10 to the 0 power. Now, when you come after the points, this would be over 10 to what power? The 7 would be over 10 to what power?
Would it be negative then?
No, well, when it is in the denominator, it's not really negative. If you move it above, it becomes negative. But as it is now, it will have a positive power. So this is 7 over 10 to what power? It is actually 10 to the 1. And if you consider the 5 as a second digit, that would be 5 over what? But that would be which column? Place value, the 100th. So that would be 10 to the second power. right? And if you have another digit, say 6, then that would be 6 over 10
to the third power.
power. And this is what gives us our decimal system, right? So the place values for the whole numbers are really in powers of 10. And the place values for the fractional parts are in powers of 10. And that's why it is called decimal. And decimals are special kind of fractions with place value powers of 10, right?
Okay.
So I know that that's a little hard to swallow, but as we go along, we will learn to appreciate more, right? But our SI system is a decimal system. That means we're working with powers of 10s. Is that clear?
Yes.
Ms. Anoshe, are you following so far?
Yes, sir.
Okay. I see Mr. Arthur is a little late. Are you hearing Mr. Arthur? Is your mic working today? Mr. Arthur, are you there, Arthurs? All right. There's some authors might never really work, so guess we have to move on. All right, so System International, it's a decimal system. We, in physics, and this is what the system look like, when we use our decimal system, we generally put them in prefixes to denote the power, right? So when we talk about deci, all right, let us go way down from the smallest one. So when we talk about milli, we are saying that that's 10 to the minus 3 power. Now, remember when you were asking me just now, Miss Morris, if it would be negative, so this 10 to the minus 3 is the same as 1 over 10 to the third power. Now, if you understand anything about indices, what happened with indices, if you have a fraction and you move the denominator above the bar, the power of that denominator. You following what I'm saying, Miss Morris?
Yes, sir, I'm hearing you. But you're in and out, so I'm getting bits and pieces.
Oh, I'm sorry about that. Miss Anoshe, are you hearing me?
Yes, sir.
Right. Were you hearing what I just said about the negative power that here, 10 to the minus 3? That one is for you, Miss Anoshe.
What did you say, sir?
I was just asking if, did you hear what I said about negative power?
No, sir.
Okay. So I was saying to you that these powers of tens in the SI system, which is the System International, the powers are denoted by these prefixes. All right. Now, if we are dealing with anything with power of 10 to the third power, we generally say kilo. We add kilo to that as the prefix that denote that you're raising something or you're multiplying something by 1,000, right? And if you have 10 to the second power, that means you're multiplying something by 100. We will call that hecto. And if you're multiplying something by 10 to the 1, we call that deca. And down here now, you find that these prefixes down here would now go to the negative power. That means these are fractional to the ones above. So decimeter now would be, when you think about it, it would be in the fraction of 1/10. You follow what I'm saying? Which is 1/10 to the power 1. And this one here, centimeter, would be in fractions of 1/100th, which is actually 1/10 to the power 2. Is that clear?
Yes, sir.
Right. And so this system that we use in measurement, we generally refer to it as the metric system. And the metric system, we have centimeter, millimeter, decimeter, kilometers. All of those prefixes are what we use in what we call the metric system. But the metric system is the same system that we refer to as the SI system, because this system is based on the decimal, meaning powers of tens. All right. So if we go back to the previous slide, we will see that the values of physical quantities, the value of physical quantity is expressed as numbers of units in the SI system. So it means that for science and any science in general, all the scientists around the world, they agreed on using this system of measurement. And why do they all agree on using this system of measurement? Is so as to have a standard of measurement that everybody will agree on. All right. So when you make something a standard, it means that everybody uses that same system of measurement. So every scientist around the world will use this same system. And it is the reason why they want to use the same system of measurement is so that wherever you are as a scientist, if I have done an experiment in Jamaica and I am using measurement of the SI system, now another scientist in China can use the same measurement system and can actually see how I derive my answers based on me using the same system of measurement, right? So they can actually make comparisons in what you are doing and what they are doing based on using the same SI system. So the SI system is a standard measuring system that is used in science. And so the various sciences that we know, they will all be working with the SI system. So you will come across the prefixes when you're dealing with different measurements. So if we talk about measurement in terms of meters, meter is the unit for what? What quantity do we measure when we are using meters? Ms. Morris? Mr. Arthur? What quantity that we usually measure by using meters? Ms. Morris, do you understand what I mean when I ask you what quantity? Are you hearing me, Ms. Morris?
sir?
Yeah, I was just asking you a question, but apparently you weren't hearing me.
What were you, what, can you repeat, please?
Yeah, so I was asking you what, if we are measuring something in terms of meter or meters, what is the quantity being measured? What are we measuring?
Length, anything to do with
Right,
length
we're measuring length.
or distance?
When I was explaining earlier about the SI system, I was here talking, but I'm not sure that you were all hearing. But I was just saying that the SI system, these prefixes that we have, kilo, hecto, deca, deci, centi, milli, these are all prefixes used in the metric system. And the metric system and the system is pretty much the same. Wherever you are in the world, all scientists agreed on using this system of measurement so that they have one standard of measurement so that everybody can work with the same standard. And there's a reason for this system too. It is also easy to count by 10, right? 10, when you're counting by 10 is one of the easiest things to do. So I was saying to you that you will see these prefixes a lot in our measurement. So if we are measuring length in terms of meters, we will add these prefixes. So the base unit would be meters. Give me a second, please. Yeah, sorry about that, guys. So the SI system, we will use these prefixes when we're. So if we have a base unit, like say for instance, the meter, the meter now would have what we consider the power of 10 to the 0, all right? So we're talking about meters. With the base unit of meter, it will be 10 to the power 0. Now, anybody knows 10 to the power 0, what that really equals to?
Yes,
10 to the 0 is anybody remember? 10 to the 0 is actually equal to 1. So if we are dealing with meter, if we are measuring in meter, then meter would be the base unit and it is measuring in 1. But if we now say decameter, or if we say decimeter, or if we say centimeter, or we say millimeter, what we are actually saying now, we are looking at multiples and submultiples of the meter. So if we say kilometer, what that means, we have 10 to the 3 meters. And 10 to the 3 meters really mean 1 kilometer is what? Anybody remember how much 1 kilometer equal to? How much meter? 1 kilometer equal how much meter?
What, is that 1,000, sir?
It's 1,000 meter. And
Right.
if we're talking about centimeter, what would that mean? How much meters? That would be 1/100th of a meter.
100 what?
1/100th of a meter.
Oh,
What it means then, to get a centimeter, you would cut up the meter into 100 parts, and one part would be 1/100th, and that 100 part is what we call 1 centimeter. You follow? Are you following, guys?
trying, sir.
Remember, no, these negative powers mean you're cutting up the meter in fractions. Now, this one, you're cutting up this into tenths. Now, remember, for a fraction, the denominator tells you what? What the denominator of a fraction tells you? What the numerator of a fraction tells you, that? Guys, are we a little shaky with the maths?
Sir, I don't remember. I did math some nice decades ago. Sir, I think the decimal place would, the numerator would tell you what part of the whole the fraction it is, and the denominator would tell you what the entire thing is.
All right.
Speaks of what the entire thing is.
Denominator tells you how much parts the whole is cut up into.
This thing has.
And the numerator is telling you how much part take out of how much it is cut up into. So this is 1 part out of 10. This is 1 part out of 100. So we are saying that these measurements down here for the meter, they would be the decimal parts of the meters. So if you're dealing with say decimeter, it is 10 to the minus 1, meaning that if you have a whole meter, you cut up the meter in 10 parts, and 1 part of, if you have, do you have a ruler with you? Do you know centimeters, and have you ever looked at your ruler? All right, this is your assignment, guys, because I want you to get a practical idea of what this is all about. I want you to get a ruler, one that is in metric. Hopefully all our rulers are now in metric. And I want you to look at the numbering on these rulers. And you should see, generally, if you're getting a ruler, it might be in centimeters. But I want you to look at what interval is a centimeter. And I want you to see how much part that interval is cut up into, and so on. You follow? And a lot of you use graph paper too. You have never used a graph paper. Have you ever used a graph paper, students?
What, sir?
Graph paper or graph leaves.
Graph.
Yes.
Right. You have ever looked at how the parts are cut into different fractions? Like the different boxes. You have tiny boxes, boxes, and so on. All right, so those are examples of how
Justin,
the
when you put the pants them pan is something, you crush them.
All right. So
No, good job learning.
when you're using fractional parts like the deci, centi, and milli, those powers are negative, right? If you're moving up now for deca, that means the meter now,
If your son was
the meter now is now times 10. So if a decameter would be 10 times a meter, right? So remember, there used to be a table now where we say 10 millimeters, 1 centimeter, 10 centimeter, 1. You remember that table? It probably on a book. You need to refresh your brain with those because you have to understand how the measurement system works when we're making measurements. All right, so just to give you an idea, so the meter is the base unit. If you're getting 10 times a meter, then you would now have 1 decameter. If you have 100 times a meter, then now you have 1 hectometer. If you have 1,000 times a meter, then now you have 1 kilometer. You follow? Guys? If you have a meter cut up into 10 parts, then one part out of it is now what we call a decimeter. If it is cut up into 100 parts and you take out one part, then that is called a centimeter. And if you think of the prefixes now, when I think of the prefixes, they are actually words with certain meaning. When you think about centi, you're thinking about what? Centi means 100, you know. When you talk about a centurion, a person that lived to 100. When you talk about a century, you're talking about 100. Deci means 10. If you're talking about deci, it means that it cut up in 10 parts. When we call a decade is 10 years, right? So based on the prefixes, you can actually get a sense of how much parts a meter is cut up into. Milli cut up into 1,000 parts. All right. So, all right, guys. So you have to kind of get familiar with this. Hopefully, as we move along, you will learn what these multiples of 10 and submultiples of 10 means. Now, these prefixes are often used with measurement. So we will have, like, in terms of meters, we may have decimeter, centimeter, millimeters, or we may have decameter, hectometer, kilometers. There are many more prefixes to it than these. These are just some of them, all right? Sometimes we may also talk about, instead of meter, where the meter is in measurement of length, the unit of length, we may also talk about grams. Now, if gram is the base unit, we may have decagram, hectogram, or we may have kilograms. And for the smaller units, we may have decigram, centigram, and milligrams. You get the idea? If we're talking about liters, we may have decimeters, deciliters, or if you want, you can say decaliter, hectoliter, kiloliter. We have deciliter, centiliter, and milliliter. Now, some of these are not very popular. You might hear about the centi and kilo a lot. And the reason why those are more popular, and probably milli, they are more popular because in the real world, you may have more practical measurement with those units than the others, all right? But in science, we rely on measurement using all of these units. Yes, Mr. Authors. Now, Mr. Authors, I'm not sure what is happening with your device, but you really need to get something so that you can interact in the class, because you won't benefit much without being able to interact. All right, Mr. Authors? All right, sir. You need to work on it very soon, because as I say, you won't be benefiting much from the class if you're not interacting. All right, any questions so far? Do you get a sense of what this SI unit is about? Ms. Morris?
Yes, sir, a little bit. It's 100, but I guess as we start using it and applying it, it will
Right.
become clearer.
Yes. And it is pretty simple now. When we are dealing with the meters, if we're having measurement in meters, it is relevant to the size that we are measuring. So if you know what a meter length is, anybody have any idea what a meter rule is? Have you ever seen a meter rule? Dressmaker have it. You ever see the dressmaker them with a meter rule?
The same thing as we call inch measure or something like that. That's what it's again.
What do they call it?
Is it the same thing they call an inch measure?
Well, not an inch measure. You see, inches is a different system of measurement, right? That system of measurement with the inch and feet and yard and so on, it's kind of different from the metric. The metric, the inch measurement is in multiples of 12, but the metric system is in multiples of 10. When we're measuring in terms of every 10 units. Now, you may be familiar with 1 foot being 12 inches. And you may be familiar with 3 feet being 36 feet. You get what I'm saying?
Yeah.
Right. Now, in a similar sense, 36 inches, which is 3 feet, is approximately the same length of a meter rule. Right?
Okay.
You will often see that long meter rule. Now, when you're measuring something, you rely on using these measuring devices, right? We may have a centimeter rule, we may have a meter rule, and we may have even bigger measuring device than the meter rule. Now, when you think—
Would the meter rule be, all right, for example, when you go to the fabric store and they have that tall ruler that they use to measure, that's it?
Yeah, that's a meter rule.
Okay.
Right.
Okay.
So if we are measuring, like say 100 meter, then what we need is 100 times